Welcome back, everybody. Now we continue with the Waec questions. This is May, June 2009. Number 1A. The position vectors of points L and M are 5i plus 6j and 13i plus 4j respectively. Let's represent that very quickly. Let this be the horizontal, the vertical axis rather, and this be the horizontal axis. Now, the position vector of L is 5i plus 6j. This is the origin O. Let this be 5 and this be 6. So the position vector of L is going to be OL, which is this. This is L. That means the position vector of L is 5i plus 6j. You can label it this way or just put 5, 6 in brackets here. That will also mean the position vector of L is 5i plus 6j. Now, the position vector of M is 13i plus 4j. Let this be 13 and this be 4. This is a sketch, by the way. So the position vector of M is going to be this vector. The position vector of M is a vector OM. This is M. Now that is 13i plus 4j. So the position vector of M is represented by the vector OM, which is 13i plus 4j. If point K lies on LM such that the ratio LK to KM is 2 to 3, find the position vector of K. In other words, find the vector OK. Now, if this is LM, let this be LM, that's the vector LM. This is vector LM. Now point K lies somewhere on LM. Point K, let this be point K, which is on LM, and it is such that the ratio LK to KM is 2 to 3. Now they want us to find the position vector of K. So let me do that. Let me make this the vector OK, which is the position vector of K. That's a vector OK. Now, how do we find the vector OK? So that's the next thing. Now, LK, the ratio LK to KM, ratio LK to KM is the same as the ratio 2 to 3. What that simply means is that we can write that as a fraction. That means LK over KM is equal to 2 over 3. Now, what is LK? The vector LK is movement from L to K. Vector LK is movement from L to K. Now, it is a movement from L to K without going directly from L to K this way. Without going directly from L to K this way. So if you don't want to go directly, you have to go from L to O and then from O to K. So LK, the vector LK is the same as the vector LO plus the vector OK. So that's what I'm going to write now. LK is LO plus OK over, what is KM? What's the vector KM? The vector Km is the movement from K to M without going directly this way. And the way to do that, the alternative route from K to M, if you don't want to go directly, is going to be from K to O and then from O to M. So the vector Km is the same as the vector KO plus the vector OM. So Km equals KO plus OM, which is equal to 2 over 3. Now, we know that the vector LO, this vector LO, the vector LO is the opposite vector of vector OK. So that means LO, vector LO is going to be the negative of the vector OL. So instead of LO, I'm going to write minus OL. Now that simply means minus OL plus OK over the vector KO is also the negative of the vector OK. So that means vector KO, because it's in the opposite direction of the vector OK. So vector KO is the same as minus OK. So that's minus OK plus OM equals 2 over 3. Now we can cross multiply here. This simply means 3 times minus OL, 3 into bracket minus OL plus OK is the same as 2 into bracket minus OK plus OM, which is the same as minus 3OL plus 3OK minus 3OL plus 3OK equals minus 2OK plus 2OM. And now we can collect like terms. This simply means 3OK. I'm bringing minus 2OK to the left hand side, and it becomes plus 2OK equals 2OM. Now I'm taking minus 3OL to the right hand side, and it's going to become plus 3OL. And that simply means 5OK equals 2OM plus 3OL. And that's equal to, we already know what the vector OM is. The vector OM is 13I plus 4J. So that simply means 2 into bracket 13I plus 4J plus 3 into bracket, what's the vector OL? The vector OL is 5I plus 6J. 3 into bracket 5I plus 6J, and that's equal to 26I plus 8J plus 15I plus 18J. And that's the same as 26I plus 15J is 41I plus, now 8J plus 18J is 26J. So this simply means 5OK equals 41I plus 26J. Now if you divide both sides by 5, that simply means the vector OK is equal to 41I plus 26J over 5. And we can write this as 41 over 5I plus 26 over 5J. 41 over 5I plus 26 over 5J, and that's a vector OK, which is the position vector of K. And that's it, very, very simply. All right, let's take a breather and then come back in a few. Thank you very much, and I'll see you in the next. Bye bye.